Welcome, ladies and gentlemen, to your MN50 notes, where we're going to talk about the volume of pyramids and cones. This is section 12.5. In 12.4, we did talk about the volume of prisms and cylinders. And you'll notice that there's a lot of similarity between that and this concept. The difference is the volume of a pyramid and a cone, since it does go or meet at a peak up here, it does cut a lot of volume off of the shape, and you'll see that in the actual volume formula. I hope to demo this in class so you can actually physically see this formula in work, I guess is what I'm going to say. Okay, it says the volume of a pyramid up here, the volume V of a pyramid is V equals 1/3 base times height. So again, the prism and the cylinder was the volume equals the area of the base, and then you multiply it by the height. This, because again, it comes up to a peak, it's not going to have as much volume. You have to divide it by 3, or you multiply it by 1/3. And I do want to mention that if you prefer finding the volume, saying area of the base times the height divided by 3, that is the same thing as multiplying by 1/3, whichever formula works the best for you. So again, where B is the area of the base, which is this right here in this problem, and H is the height. And be careful, a height of the pyramid has to go from the peak, the vertex up here, down to the base at a 90-degree angle. Not a slant height, we're talking about the height of the pyramid. That's what you would need to use in to find the volume of this pyramid, or any pyramid actually. The volume of a cone is the same idea. Its volume equals 1/3 times the area of the base times the height. Because the base here is a circle, you can say that it's 1/3 pi r squared, which is going to be the area of the base, times the height. Now I do want to stress again that if it's easier for you to go pi r squared times height and then just divide that answer by 3, that will give you the same thing. I tend to not like multiplying by 1/3. Okay, so let me show you how this all works out here. So we have example 1, find the volume of a pyramid with a regular base. So notice this base, as you probably are cringing, is a 1, 2, 3, 4, 5, 6, a 6-sided hexagon. And I'm going to just draw my bottom of this hexagon. We've done this many times, haven't we? So we have 4 inches on the base, but we still, in order to find the area of this, we need to find the height. So we have, if you go 360 divided by 6, you have, what is it going to be? 60 degrees. That gives me 30 degrees right here. So I'm going to bring this right triangle out of there. This is 2 inches. This is 30 degrees, and this is the height. So we have tangent, tan of 30 degrees is equal to the opposite, which is 2 over h. And you would find that when you cross multiply, that you have the height is going to be 2 divided by tan of 30. And this gives you 3.46. Now, just as a reminder, this is over here, this right triangle. We use tangent, but we could have just used special triangles where we could have taken 2 and just multiplied it by the square root of 3. That would have given us the same answer as this 3.46. Just thought I'd throw it out there as a good reminder. Okay, so let's kind of find just the area of the base, because that's a biggie, right? Okay, so we have the base of the triangle within the hexagon is 4 inches times the height we just found, which is 3.46, divided by 2. So that's our one triangle. That is this right here, over here. And then we take that and multiply it by the amount of triangles, which is a hexagon, so it's 6. And that will give us an area of our base of 41.52, or I'll just say 0.5 inches squared. Okay. So all I've done so far is found the area of the base of the hexagon of this pyramid, so, because it is a hexagonal pyramid. Now, I'm going to switch this over. We're going to talk about volume. Volume. is equal to the area of the base times the height of the pyramid divided by, not 2, 3. And again, that's kind of how I do it, just because, again, I don't like having to multiply things by 1/3. The area of the base we have over here, which is the hexagon, 41.5, times the height of the pyramid. And I do want to point out that this pyramid looks like it's slanting. I realize that. It's not going to matter as long as you have the height from the vertex down at a 90 degree, and of course they're not showing it, so I guess you have to take my word for it here, that this is the height of the pyramid, which is 10 inches. So it does not matter if it's a slanty pyramid, oops, it's just 10 inches, it's still, as long as you have that height, you're good to go, which is kind of strange, I realize. Okay, so we multiply this, the 41.5 times 10 divided by 3, and we will get a volume of 138.4 inches cubed. Okay, that is how you find the volume of a pyramid. So we find the area of the base, just like we did before in prisms, and then we multiply it by the height, just like we did with prisms, but this case we divide by 3 because it is a pyramid, and you have to remember that you have to divide by 3 or multiply by that 1/3. Okay, so now you'll notice the cones are not much different. Again, we have to find the area of the base of the cone, which I'm going to just, oops, I did something kind of strange there for a moment. The area of the base is going to be pi r squared. So that's going to be pi times 6 squared, which is going to give me, oh, I don't even have it here. I have to grab my calculator. Give me just 1 minute. 36 times pi. That is going to give me an area of 113.1. And that is the area of that base, which is a circle. Now, when we do volume, it's going to be volume equals area of the base times the height divided by 3. The area of the base we just figured out down here is 113.1. Oops, I can write that a little bit better. 113.1. The height is an issue. I cannot stress enough that you need a height that goes from the vertex of the pyramid or cone down at a 90-degree angle. Notice that what they're giving you is what we call that slant height. It's slanty. It's not the height that we need. So if you look what we have, though, we do have the hypotenuse. We have a leg, so we can use Pythagorean theorem quickly. So we have a squared plus b squared equals c squared to find that height. So we have, oops, I don't want to call that c, I'm sorry, actually I'm going to just call that h because that's what I want to call it. Okay, so we have 6 squared plus h squared equals 10 squared. We solve that really quick, and we've done this lots and lots of times, haven't we? We find that the height is 8. So I'll put the height right in here. So we have the base of the cylinder, the height of the cylinder, and of course we need to divide that by 3. You throw that in your calculator, you're going to get 301.6 feet cubed. Okay, again, nothing too complicated here, just kind of extending everything we've done, getting a little bit more practice with finding the areas of the bases, especially those pentagons, hexagons, octagons, and so on. Here we have another cone. The difference with this one is we are not given the radius, which is kind of a big deal. We need to find that. Notice they're giving us an angle of 62 degrees. They give us a side opposite, but we need this r. Notice it's the opposite side right there, adjacent side we want. So we're going to use the tan of 62 degrees is equal to 12 over r. We'll put this over 1. I cross multiply, so I have r times the tan of 62 is equal to 1 times 12, which is 12. I divide out by the tan of 62, so I have r is going to equal 12 divided by that tan of 62, which if you calculate that out will give you a radius of 6.38. Okay, now that we have that, we can find the volume. Volume equals the area of the base times the height divided by 3. The base, in this case, again, is a circle. So the area of that is going to be pi times the radius we just found squared times the height of this cone, which is 12, and we divide that all by 3. So again, this is the area of the base, which is the circle, times the height divided by 3 because it is a cone, not a cylinder. When you calculate that, you will get 511.5 meters cubed. Okay, I'm hoping you're enjoying the volume a little bit more than what we had the surface area. Surface area does take us a little while, so this is kind of a nice change of pace. I have one more example here to show, and then from there you're going to show me that you understand what's going on by doing the bottom two problems once I'm done with this example here in example 4. It says find the volume of a composite solid. So you'll notice you have a cone on top of a cylinder. So we do need to find the volume of both. Let's start with the volume of the cylinder. And I'll just do this to make sure we keep it organized. We have the area of the base times the height, not divided by 3 because we're talking about a cylinder here. The area of the base is pi times the radius, which is 3 squared. So there's my base right there, times the height of that cylinder, which is 7. And that will give me the volume of my cylinder, which, be careful when you're doing this, 3 squared is 9 times pi times 7. That's going to give you 197.9 centimeters cubed. Okay, so that's an important number right there because we're going to add that to the other volume. So we just found how many cubes fill up that cylinder, which is 197.9 cubic centimeters. Now I'll do the cone, volume of the cone up here in green. So volume of the cone is equal to base times height divided by 3. The base, again, is a circle, so it's going to be pi times radius squared. Right there, there's my base, times the height of this thing. Now let's just make sure they're showing us the true height, and they are. It's going from the peak down, it's hitting the center point, so we know it's hitting at a 90-degree angle. So that is going to be 3 centimeters right there for height, and we want to divide it by 3. So this, clearly you need to be careful when you're doing this because it's 3 squared is 9, 9 times 3 is 27. So we have 27 pi divided by 3. You can go 27 divided by 3 is 9 pi. Throw that in your calculator, and that will give you 20, I don't want to put it up there, 28.3 centimeters cubed. So that is the top cone. The blue is the cylinder. You add these two together. So you're taking 197.9 plus the 28.3, and that is going to equal 226.2 centimeters cubed. Alright, that would be the total volume, if this were drawn to scale, how many little cubes, centimeter cubes, that you could fit inside of this shape. Okay, I hope everything was understandable. Now I want to see what you know. So down here it says, now show me you understand kind of problems. It says problem 1, find the volume of the pyramid with a regular base. Notice it is a 1, 2, 3, 4, 5, 6. It is a hexagon, much like our first example. And then here, problem 2 is a lot like our example from up here, number 3. So I'll take any questions from you tomorrow. Have a great day. Thanks.